discussing the synchronous machine. As we discussed, inshallah, help session will be at next Saturday at 12 p.m. at noon. It will be made on Zoom. I will send you the link on Blackboard later, and inshallah we will record it and send it to Blackboard. Last class, Shabab, we discussed the meaning of synchronization, and we discussed the meaning of infinite bus, and we agreed together that in order to connect generator to infinite bus, we have to fulfill 4 conditions. What are the 4 conditions, Shabab? What are the 4 conditions to connect generator to infinite bus?
Same frequency and same phase.
Yeah.
Same phase.
Same sequence.
Same sequence. ايه تاني؟
Same frequency.
Same voltage.
تمام. هم دول ال 4 conditions. Same voltage, same frequency, same phase shift, and same phase sequence. طيب. Let's see يا شباب just review small part regarding phasor diagram. For the phasor diagram you see here, which one is not fulfilled from the 4 conditions? We have 2 sources, E small and E capital. So for phase A we have E A small and E A capital. As you can see here, we have generator small A B C and the grid as capital C letters. تمام? Now in this phasor diagram, which condition is not achieved? ها شباب. What about the phase shift? Is there phase shift here between the 2 sources?
No, they in the same shift.
The same, because as you can see, phase A small and A capital are in phase, B small and capital are in phase, C small and capital are in phase. يبقى phase shift here is
the magnitudes are not the same.
Exactly. The voltage magnitude here is not equal. As you can see, the vector here is smaller than the large vector here. So here we have a problem in the voltage magnitude. For that we cannot connect these 2 sources in parallel. طيب هنا شباب, if we have first source number 1, capital letters, and here small letters, the same directions. However, frequency is not the same. As you can see, شباب, this leads that at another instant, and this is at instant T1, at another instant there will be a phase shift, and there will be a voltage drop. So here we cannot also connect the sources in parallel. But for this shape, شباب, what is the condition which is not fulfilled here?
The sequence?
Frequency here, it was clear. At instant T1, it was in phase, and after that, a phase shift is appeared. So frequency is different here. However, here we say that both of them have the same frequency. So here we have phase shift, شباب. Equal phase shift between A small and A capital. The same is for B and C. So also phase shift will lead to a voltage difference. But for this shape, شباب, actually this shape we have 2 conditions are not achieved. What are the 2 conditions here?
Phase shift and phase sequence.
Exactly, you are right. Phase shift and the phase sequence are not appeared here. طيب شباب, now how we can achieve the 4 conditions practically? Practically, شباب, we have something called synchronoscope or synchronizer. This synchronizer in power plants, it controls the generator in order to achieve the 4 conditions. In terms of the 4 conditions, شباب, how we can achieve the 4 conditions now? We have or we need to change the voltage. How we can change the voltage of the generator? Simply we have generator voltage
transformer
EG or EF, whatever, EF equals V terminal plus IA multiplied by the impedance of synchronous machine RA plus JXS, which is equal 4.44 multiplied by flux multiplied by frequency multiplied by number of turns per phase. So how we can now change the value of V terminal if we would like to change the voltage of the generator? How we can change V terminal?
Stepping up or stepping down using transformer.
لا يعني transformer in the generator. لا you understood me wrongly. لا أنا قصدي the grid voltage, for instance, the grid voltage here, the RMS value of the volt here is 12 kilovolt. Okay, and the voltage obtained here from the generator is 11.8 kilovolt. So how we can control the voltage to reach to 12? From controlling the parameters here يا شباب, which parameter that we can use in order to change the voltage?
The
RA.
RA is the resistance of the machine. We cannot add resistance to this machine. It's not like speed control of DC motor, for instance. Here we have synchronous machine, which is a generator, and it will be connected to grid. It's not logic to add resistance just to change to increase the voltage. Okay, or control the voltage, because we cannot increase the voltage by adding resistance even. So R and X, يعني parameters, cannot be changed. Also current, we cannot access the current because current will be absorbed by the load. So we have no access for current. We should find any other thing.
The number
We have VT left.
Sorry?
We have VT left. That's the only thing we can change, I guess.
Whatever, يعني moving or not, يعني VT can be controlled here by what from this equation? Which parameter that we can control? We have generator.
N.
This generator N is the number of turns per phase. So this is related to the winding of the machine. We cannot control the winding.
The flux.
The flux, doctor.
Flux, exactly. This is the only way. So we can change the excitation in order to change the value of voltage. So if we have difference in volt now, we can change the excitation from here in order to achieve certain volt. This is number one. If the frequency is not adjusted, how we can achieve the frequency condition? شباب, how we can change the frequency of the supply here?
Through speed.
Exactly. So by controlling the speed of prime mover, we can change the frequency. So this is number two. So now we know how to change voltage and frequency. What about phase sequence? طبعا phase sequence يا شباب, يعني it's very easy. If the phase sequence is not fulfilled, it means that the phase sequence is reversed. It's not ABC. So we have to convert just the sequence to ACB by changing two terminals together. تمام? This is going to change the phase sequence from ABC to ACB or ACB to ABC. So phase sequence يعني easily can be changed. طيب, for the phase shift, how we can change the phase shift يا شباب?
Power factor.
لا, power factor, this depends on the load. يعني power factor, if the power factor changes, the sinusoidal waveform of the supply of the voltage will not be changed. يعني let's see together on the waveform here. As you can see يا شباب, we have two generators now, generator 1 and generator 2. Now if we could fulfill the voltage, as you can see the peak volt is the same for the two generators, and if we both of them together here, you can see it's same frequency as well. Okay, and we will assume that sequence is okay. We have no problem in sequence. However, we have shift like that. How we can, from the curve here, how we can achieve the same phase shift? How we can move the G2 left or right? Practically. Can you imagine, Shabab, if we change the frequency now, like that for instance, what will happen to the zero crossing at the end?
They will be equal to each other.
Exactly. However, the beginning is different, so the frequency changed. So we have to increase the frequency again. So by stepping up or stepping down or increasing or decreasing the frequency, you can achieve the same phase shift. However, it takes time in order to tune the frequency to get the same phase shift. Okay, Shabab? So this is regarding the phase shift. Phase shift can be adjusted by adjusting the prime mover speed of the generator. طيب.
دكتور معلش الفيس شيفت اللي قبل شوي كان بين مين ومين؟
Phase shift between two sources, generators or generator and infinite bus. Okay?
تمام.
And we need to adjust the speed of adjust or fulfill the four conditions of synchronization. طيب. Now, Shabab, if we would like to make it in laboratory, assume we have generator like that, and we have infinite bus. In order to detect, as you can see for the four conditions, here the voltage is not equal, it leads to delta V. So we have delta V here. If the frequency is not equal, it leads also to delta V. If the phase shift is not equal, it leads to delta V. If the phase sequence is not equal, it leads to delta V. So all of cases lead to voltage difference. So if we add some lamps between the source and generator, in this case, if the lamps are turned off, we will be sure that the voltage drop across lamp is 0, and in this case we can connect the generator to infinite bus. طبعا this experiment is one of the experiments in the course EE462 تمام. And we can make it in our laboratory. Even I'm not sure in E360 lab why the lab is in the recorded video did you see the lamps or the synchronoscope device in our lab or not. However, we have this experiment in our lab in another course, and we could fulfill the synchronization condition easily. Right. So this is Shabab regarding the synchronization. Now, in another important part, which is the synchronous reactance. Synchronous reactance, Shabab, is very important to be identified. In terms of power system, in order to control the power and transmit the power and control also the reactive power, you have to use XS. And we will discuss, inshallah, in the class, the relation of active and reactive power. And you will see that it depends on the value of XS. So we need to control, we need to identify the value of XS. This is very important for synchronous machine. And also for any type of machine, Shabab. The parameters of the machine are very important to be identified for speed control, for torque control, and so on. Okay, so here we need to identify the value of synchronous reactance. How we can do that? Simply, if we have, Shabab, impedance. However, this impedance, we have impedance in a network, but this network includes many elements. Like for instance, it has some controlled current source and some resistance and capacitance. Okay, some elements complicated like that, Shabab. And finally, we will have only 2 terminals for this device. I'm not sure, do you learn the something called 2-port network or not yet? Did you learn, يا شباب, something called 2-port network?
Yes, Doctor.
Okay, 2-port network. If we have 2-port network, how can we identify the parameter inside this network, يا شباب? And we have here, we need finally one impedance to represent the equation of the 2-port network. How we can get the impedance here, يا شباب?
We were used to use matrix and make if we use V1 we make V2 equal to 0, and we use the current.
Let's simplify it instead of 2-port network. Did you learn something called Thevenin equivalent circuit?
Thevenin, yes, we use.
How we can get Thevenin, يا شباب, for this machine? We have a machine now with many elements here, and we just would like to get the relation or the impedance of this network. How we can get it?
Put a voltage test.
Both a voltage source.
Voltage test.
And then
find the resistance seen by the voltage source.
Yeah. Then
measure the current.
If we can find the current, we can measure the resistance.
Did you make it like that in the in calculations of Thevenin? I believe in Thevenin calculation, يا شباب, if you have dependent sources like that, you cannot achieve the equivalent impedance directly. I mean mathematically. You have to make or calculate first V open circuit, then you calculate I short circuit. Is it right?
Yes, this was one of the methods. Yes.
And finally, we get Z as V open circuit over I short circuit. Tamam? This is if the circuit is complex, شباب. The same is here also in our machine. Machine is not only sum of R and L. You have EMF. Inductance is not constant. Inductance is varying during the operation of the machine. So how we can obtain the value of synchronous reactance? We have to make 2 tests. These 2 tests are nothing but open circuit and short circuit. It's similar to Thevenin equivalent or obtaining Thevenin equivalent circuit. So let's say, شباب, we have the synchronous machine like that. This is the winding. We have here field winding, and we have 3-phase stator winding. In open circuit test, we will leave the stator open circuit, which means no load, and we will change the value of field current and record the value of obtained voltage. So this is called open circuit test. From this test, we expect to have the characteristic, which is called the magnetization curve, or the relation between IF and EF. This is for the open circuit characteristic. So when we make this test, شباب, it will lead to have this characteristic. It's called open circuit characteristic. In this characteristic, we will use some other points to define 2 different curves. One is called air gap line, and the other is called modified air gap line. In air gap line, شباب, this air gap line assumes that the magnetic core of the machine is ideal, which means there is no saturation. So if there is no saturation, we can find the curve of air gap line like that. How we can plot this curve? Just start from 0 and make tangent to the characteristic like that. This is called the air gap line. Another line is called the modified air gap line. Modified air gap line is very important for the machines. Why? If we have a generator supplying a certain load, شباب, without any connection to other generators or to infinite bus, we call it as independent generator. For independent generator, we can find the relation between IF and EF simply using open circuit characteristic. So the saturation or saturated open circuit characteristics are used when the generator is independent. Independent means not connected to infinite bus. Fine. If we consider the core of the machine is ideal, so we can get something called unsaturated curve. Unsaturated curve, which is the air gap line curve. This is the ideal case, شباب. However, if the generator is connected to infinite bus, the point of connection of the generator to infinite bus is nothing but the rated voltage of the generator. So this point, this is the rated volt. When we connect the generator to infinite bus شباب, is very huge system. It has constant voltage and constant frequency. So if a generator is connected to infinite bus, it's assumed to have linear characteristic like that, starting from 0 and pathing to this point of rated voltage with the intersection of open circuit characteristic and continue linear like that, شباب. So this is the modified air gap line, which is used when the machine or generator is connected to infinite bus. Type. This is regarding to the relation between EF and IF at different conditions. So we have three relations between EF and IF. One is called open circuit, one is ideal called air gap line, and one is actual and used when the generator is connected to infinite bus and called modified air gap line. Type. So this is for the first test شباب of open circuit. The other test or short circuit test is made by the same way. We get the machine and make a short circuit on the armature winding, add ammeters in order to measure the current, and we know that we assume all of time that the machine is we call it as identical, or three phases are identical, so it's balanced all of time. So the three impedances are equal and the current also will be equal. So it's sufficient to use only one ammeter. However, we can use a 3 to check the accuracy. طيب. In this test شباب, we start field current from 0 and increase it and monitor the value of armature current. However, you have to take care about the rated value of current. You shouldn't increase the field current when the armature current reaches to the rated value. Otherwise, you may damage the machine windings. So this is called short circuit characteristic or short circuit test. From short circuit test شباب, we can plot the short circuit characteristic like that. We have many points between IF and IA, and we can plot this curve. And this curve شباب is linear curve like that. Okay. Type. So if it is linear curve, we know that only one point is sufficient to draw this curve, because we know the other point is the 0, 1. So we have 0 point and another point on the curve can be sufficient to draw this curve. Type. Now, after getting the different curves, how we can obtain the value of x? There are two different values of x are considered. One is called ideal or unsaturated, which is calculated using air gap line, because there is no saturation here, and this is considered as ideal. And the other one is the accurate one, or exact value, and we call it as saturated, and it's calculated from the open circuit test. How we can get it, شباب? Simply, after plotting the air gap line, identify the value of IF where the open circuit, the voltage is rated from the open circuit characteristic. So we can go to the value of V rated and make a horizontal line until intersect with the open circuit characteristic. At this point, you can make vertical line like that. The intersection with the air gap line will be the required voltage, and the intersection with the short circuit characteristic will be the required current. So for now, we can say that volt AD between A and D over current AB equals Z unsaturated. So as you can see here, the relation Z unsaturated equals EDA over IBA. It will give you the impedance of the machine, which is RA plus JXS unsaturated. And يعني resistance شباب is very small in large synchronous machines, so we can neglect. طيب why شباب resistance is very small? What is the relation between the power of the machine and the resistance of the machine? Why we say if the machine is high rating, resistance can be neglected?
Because the voltage will be very high, Doctor.
Is it related to voltage?
Yes, because the power is related to the voltage.
Actually, the resistance, we care about what in resistance should be. What is the resistance value or resistance design? What is the relation of electrical resistance? If we have a wire, what is the resistance of this wire?
To have losses.
Rho L over A.
Rho L over A, this is right. So resistance equals rho, resistivity, multiplied by L over cross-section area. If the machine is high power machine, the current will be high. And if the current is high, the cross-section of the winding should be high. So that the resistance value will be very small. So for any large machine, if the power is high, we expect high current and low resistance. And if the machine is small, so we expect to have small current and small cross-section area, and this leads to high resistance. Okay, شباب, for that, you will find that machines of high rating has small resistance and small copper loss compared to the in per unit compared to the small machines. تمام؟ طيب. So we can say here شباب neglect RA, and in this case you will find that XS unsaturated equals EDA over IBA. طيب. For the other value, which is important and we use it in problems, the actual value of XS, how we can get it شباب? Simply from the open circuit characteristic itself, it's equal to the rated value of volt over the corresponding corresponding rated current. Okay, so it's equal to ECA here like that, V rated over the value of ARBA. Type. This is the value of saturated impedance, and by the same way شباب, we can neglect RA and calculate the value of XS saturated in that way. Right. By the way, if you read this part in the textbook, you will find that another solution for this problem we will discuss here using something called M per unit calculation. And I believe you did not take per unit calculation before, and the course here is has a lot of material, so we will consider only the actual calculation. Okay, we will not consider the per unit calculation. Right. For this example, شباب, it's stated here: 3-phase 10 megavolt ampere 14 kilovolt are connected synchronous machine has the following test شباب, and as you can see we have different values for field current, we have corresponding different values of voltage, but it's stated here that this is line to line volt, so it's not phase, so we cannot say V over I equals Z. We have to first get the phase voltage, is it right? In order to get the impedance. And you have only one point for air gap line and short circuit current. طبعا air gap line is linear curve, so 1 point with 0 is sufficient. And the same is also for short circuit test, short circuit current. You can plot the short circuit characteristic by the meaning of 1 point and the 0 point. Right. What is required here? Find the saturated and unsaturated synchronous reactance, knowing that RA equals 0.07 ohm. So it's given in the example, RA equals 0.07 ohms. So simply we can plot the characteristics. We have the characteristics of open circuit, so we can plot the curve. And we have also the air gap line characteristic, it's given. And we have as well the short circuit characteristic. Actually, we can solve this problem without plotting. If we need to calculate the values of synchronous reactance, we don't need to plot, because you simply know that Z unsaturated equals V of air gap line over I, is it right, شباب? At the value of rated voltage. So the air gap line, this is line value, so we can say here phase, okay, over I at the field point of the rated voltage. Now, what is the field point of the rated voltage here? It's stated that the voltage is 14 kilovolt, is it right? So at 14 kilovolt, you will find the field current is 200 ampere, and the air gap line is 18, and the current, the short circuit current is 490. So you have all of data given here from this line, and you can calculate it. So we can now say the value is the air gap line as a phase value equals 18 kilovolt over square root of 3 kilovolt over the value of armature current, which is given by 490. So this will give you the value of Z. You have the value of resistance, so easily you can get X as square root of 2 Z square minus R square. So this is for saturation. Type for unsaturated يا شباب Z
Doctor,
sorry اتفضل.
why did you use the air gap voltage? Why didn't you use the 14?
Because we need first to calculate the unsaturated. We discussed here the unsaturated obtained from the air gap line. This is the ideal value. And it's required here to calculate the ideal and the actual. Okay?
Yes, okay.
So for the unsaturated, we calculate it from the air gap line, because this is the ideal one. Right? For the saturated curve, which is the open circuit characteristic, we can say Z saturated equals V rated phase divided by the value of IA, which is given at the same value of the V rated from the curve. So we can say here it's 14 kilovolt over square root of 3 divided by the same value of the armature current. So this will give you the value of of saturated synchronous impedance, and you have the value of resistance. You can easily get the value of synchronous reactance. So these are the numbers here, شباب. Z unsaturated equals 18,000 over square root of 3 divided by 490. This is the value of impedance. And you have resistance of 0.07, so simply you can get the value of reactance. Can you see now the value, شباب? Impedance and reactance are almost the same. Because the resistance is very, very small. Fine. By the same way, for the saturated value, you can use the rated voltage over square root of 3 divided by 490 and get the value of impedance. And by the same way, you can get the value of synchronous reactance. Fine. طب why we use curves شباب؟ يعني if we need some other requirements after that, we will give you, for instance, operating condition, certain value of field current, for instance, to get the EMF and start calculating the problem using curves. تمام؟ Torque and power of synchronous machine. This is very important part يا شباب. يعني what is the value of power of synchronous machine? طبعا you know, for any electrical system, the power S equals V multiplied by I conjugate. طبعا يعني we say this per phase. تمام؟ يعني if it is 3 phase we should multiply ايه 3 V phase I phase A conjugate. تمام يا شباب؟ طيب V is V terminal of the generator. Okay? I is the current of the armature. Here we need to calculate the value of S in terms of EMF. Okay, how we can get EMF يا شباب? From the equation, let's calculate I from the equation. Let's assume here EF equals the terminal plus I armature multiplied by Z. So we can say here IA equals EF minus V terminal over Z. Is it right? So if you multiply now and in angles, it's equal to EF at angle delta minus V terminal at angle 0 divided by at angle theta Z. When you substitute by IA conjugate here in the equation, you will find that V multiplied by I will be V terminal multiplied by EF over Z at angle theta S minus delta, theta S minus delta. طبعا يعني why it's minus? Because we need current conjugate. So the angle here in the numerator will be delta, and in the denominator will be minus theta Z, so it will be inversed. So the angle here is theta minus delta minus V terminal square over ZS at angle theta. So this is now the equation of complex power. This is per phase يا شباب. طيب the active power is considered as the real part of the apparent power. So we can say this magnitude multiplied by cosine angle. So power equal V terminal EF over ZS cosine theta S minus delta minus V terminal square over Z cosine angle theta S. So this is now the active power. The same equation will be reactive power, but by replacing cosine by sine. So this equation now represents reactive power. As we consider the شباب, the armature resistance is very, very small. If we apply that in Z, so if you apply Z S equals only R, which means theta S equals what يا شباب? Huh? If the resistance is only Z, so if R equals 0, so Z equals JXS. So theta S equal what يا شباب? 90 degrees. This is right. So we can now replace the absolute value of Z by XS, and we can replace the value of theta S by 90. If you apply this in the active power equation, you will find that the relation ZS will be XS, so it will be V terminal EF over XS multiplied by cosine 90 minus delta, which is nothing but sine delta. And here cosine 90 equals كام يا شباب؟ cosine 90 equals 0. صح؟ So this part will be omitted from the equation of power. So in this case شباب, you will find that the power of طبعا لو 3 phase يبقى power of 3 phase equals 3 V terminal EF over XS sine delta. طبعا any part besides the sine wave we can call it as the maximum value. So we can say that this is B maximum sine delta. So B maximum is 3 V terminal EF over XS. Delta, we call delta as power angle now. Why? Because it's very clear. The power is proportional to the value of delta. تمام? So we can say the angle delta is the power angle. تمام؟ طيب, if this is B maximum يا شباب, so we can say that B equal B maximum at delta equals what? When the power will be maximum يا شباب, when delta equals what?
Pi over 2.
Pi over 2. تمام? So if delta is pi over 2, you will find the power is maximum. As you can see here, this is our relation B versus delta. At delta equal 90 degrees, you will find the power here is maximum. Right. So we expect also the machine torque will be maximum at that point, because the electrical torque is nothing but power over omega. So this will be the curve also of electrical torque of the machine, induced torque or electrical torque. So we can say maximum torque يا شباب equals 3 V terminal EF over omega XS. This will be the maximum value of torque. And we can say also the torque equal T maximum sine delta. So the value of the delta شباب, or the name of angle delta, we can call it as power angle or torque angle, because it's the same. Okay, here the power depends on the value of delta, and here also the torque depends on the value of delta. So we can say delta is the power or torque angle. Fine. Also, by making the same here for the reactive power, substituting with JXS instead of Z, so you will find the absolute value of Z is XS and delta and theta equal 90. So you will find that Q equal 3 V terminal EF over XS cosine delta minus 3 V terminal square over XS, and this is the value of reactive power. Right. Now يا شباب, the point of maximum power here is very important. We have to recognize this point and understand it very well. What is the meaning of the machine is working at maximum power? And if we have a machine, and we said in the headline of the problem, a machine, like for instance for the previous problem here, we stated that 3-phase 10 megavolt ampere. What is the 10 megavolt ampere? What's the meaning of 10 megavolt ampere?
The apparent power.
Apparent power of which operating point?
Maximum.
Rated.
Rated. Exactly.
Yes.
Rated value, not maximum. Rated is different to maximum. Rated value means the value that it is recommended to operate the machine on it. So the meaning of rated value is the value that the machine is recommended to operate. تمام يا شباب? However, the maximum value, and sometimes called the critical value, which is the value if you reach it to it, the machine will be damaged. So you cannot work at maximum. Maximum is critical point. So we have to identify the maximum in order to avoid operating the machine close to maximum, not even at maximum power point.
Could you give us example in our real life, Doctor?
Our real life. Okay. For instance, if you have a motor, بلاش خليني اشوف لك example ثاني. يعني like in your circuit at home. Okay, in your circuit in the miniature breakers at home. If you would like to size a miniature for your load, for instance, you have iron or heater, okay, and this heater draws a current of 25 ampere, okay, and this is rated current of the machine. So you should protect this device by using something called miniature circuit breaker. You know the panel, the small panel you have in your apartment, it's called switches, protection switches. It's called miniature breaker, شباب. Okay, right. The value that we should select on this breaker should be the same value of the rated current of the load, which is, for instance, here, if it is 20 amps, so you should select the switch from 20 to 25, like that. What will happen if a short circuit happened on this heater? Short circuit means, شباب, the impedance is 0. So this means theoretically the current will be infinity.
والفيوز تنحرق.
But this is miniature, it's not fuse. Miniature will be disconnect. طيب, when the miniature will be disconnected, is it at 20 ampere or higher than 20 ampere?
Higher than 20 ampere.
It should be higher because 20 is the rated value. طيب, there is something called overload, يا شباب. We can operate the machine or any load to be overloaded, but for certain time. However, if we reach to twice of the value of current, this will be the maximum value. يعني ممكن المثال ده يكون برضه صعب عليكم شويه لان انتم ما خدتوش بروتكشن. طيب يعني let's have assumption for the car. You have the car meter, العداد بتاع السياره. تمام؟ You can مثلا drive the car at 200, okay? More than 200. But can you reach to the full scale of the meter of your car?
I don't think all car can do this.
It's not possible, صح?
Yes.
But the scale is there in the car, تمام? But it's there in the car to say to you this is maximum. You shouldn't reach here. Otherwise, the car will be damaged. The motor will be broken because of the speed will be very high. The bearing of the motors will be damaged and so on. So this is an example for the maximum, شباب. يعني all of time maximum value means the value that you shouldn't يعني reach to it, otherwise it may damage the machine. Right. For that we discuss or we need to recognize the maximum power for any machine. يعني I think the time is due now. يعني إن شاء الله next class we will continue discussing this point in more details because the maximum power condition is very very important. Any question شباب؟
Yes. طب دكتور ما دام إنه إحنا ما نبغى نوصل للماكسيموم فاليو، ليش ما نخلي على كل حاجة يعني زي ما تقول سيركت بريكر، يعني أول ما تيجي توصل الماكسيموم تكسرها.
Now it's already used but not used at maximum because if you reach to the maximum the device will be damaged before the breaker disconnect. So you should design it to be lower than maximum. تمام؟
تمام.
يعني the sizing of the circuit breaker for loads يعني I believe you have protection course إن شاء الله in 400 levels. يعني this course is very important also يعني you have to know how to protect devices and how you should select your breakers in order to protect any device. طيب. Any other question يا شباب؟ اوكي see you ان شاء الله next class شباب.
يعطيك العافية.
الله يعافيك برعاية الله.